Today I will start my part of the course and sandwich it in between one more lecture that Professor Omo will give next week before it gets into the main latter part of the course that I am concerned with entirely. So I will try and direct it to something that sandwiches in between as well as possible, and that is climate in relation to where grapes grow. And I will apologize to the, I think, 4 students who have had 116 because some of it is going to be repetition, but here's an area that I can't see where we can avoid it, and that is the significance of temperature, degree days, climatic regions, and so forth that we will be discussing this afternoon. But it is important that we have this information. We know what we're driving at here in terms of all of the changes that occur in the fruit and certain cultural practices as they are influenced by these climatic factors as they affect grapes. Grapes grow in the world roughly between the 50-degree parallels north and south latitude. If you can think of a band around the world, practically all grapes, especially the vinifera, is pretty much restricted to that belt, which is pretty wide. Now, of course, within that belt, the areas are widely separated in where grapes are grown for additional climatic regions, or reasons. This band is largely because of temperature in the first place. They will grow on most any kind of soil. The vinifera particularly is very tolerant to different kinds of soil, but I'm not going to go into that because we don't need that part now, and that certainly is treated in great depth, figuratively speaking as well as literally, in the 116 course next spring. They certainly grow at a wide range of altitudes, as low as over 200 feet below sea level in California in the Coachella Valley, and as high as about 4,000 feet in Owens Valley. They grow even as high as 9,000 feet in Bolivia. The reason they can grow at higher altitudes there is it's nearer the equator. Now, the reason largely for a restriction on altitude with grapes is, first, is there enough temperature to grow the grapes through the season, high enough temperatures? And what probably is even more important, there is usually a much greater hazard of spring frost at the higher altitudes. Because at the higher altitudes you get a much greater diurnal fluctuation in temperature normally than you do at the lower altitudes. And of course, with that situation in the spring, with a vine just starting growth and those very tender little shoots and the flower clusters on them, temperatures even 2 or 3 degrees below freezing can eliminate the crop for that year. And unfortunately, we have areas that are not necessarily in high altitudes that suffer this fate occasionally here in our own industry, Napa Valley, as well as down in the San Joaquin. As a matter of fact, they can have these spring frosts in the Coachella Valley, which is 200 or more feet below sea level. So you're not immune from them even if you're well below those high altitudes. But this is one of the hazards. The topography, as I say, they grow a wide range of altitudes. They're separated in districts, not only in the world, depending on climatic restrictions, particularly temperature. But let's go into some of the other factors as they control where grapes can be grown as well. Now, thinking of winter temperatures, the Vitis vinifera is killed, or essentially so, if temperatures drop to something in the nature of a 0 Fahrenheit. Now, this is a very arbitrary figure, and it's becoming more arbitrary as we're learning more about the behavior of the vine, as this killing point, so-called, may be higher or lower than that figure. Dr. Clore up in the irrigation station in Washington, where incidentally it's the winter temperatures that is primarily the limiting factor, or at least poses the greatest hazard to growing vinifera in the Yakima Valley. It has a climate very similar to the San Joaquin, the temperatures don't get quite as high. In fact, that's in favor of the vinifera. But they do occasionally in the winter get those severe low temperatures down to as low as 0 or even lower. But Dr. Clore has also found that vinifera will kill quite severely or quite completely, even if a temperature of, say, 15 or 10 degrees Fahrenheit, if the freeze occurs early in the fall before the vine is fully dormant. So there are other factors besides just the temperature per se, the degree of dormancy of the vine. And of course, these factors are becoming very important, particularly in those areas where they are now trying to grow vinifera: Washington, New York, Michigan, and other eastern states, as this tremendous focus is brought to bear on particularly table wines and the growing of premium vinifera varieties to produce them. The same is true in New York. They also have the winter kill problem, and of course their attention there is towards cultural practice that can alleviate this winter kill, looking to hopefully cold-resistant varieties of vinifera. As I say, the cultural practices that possibly might alleviate this: trellising, vine covering, and so forth. In Washington, has been especially regular practice to cover the vinifera vines in the fall with straw and even earth on top of that, and then bring the vines up in the spring. And this, of course, is the practice that will almost ensure that you won't have your vines killed by these sudden deep freezes that they get. But as you can guess, this practice is very, very expensive in more ways than one. Just the physical handling of vines, putting them down, covering them every fall, and then bringing them up in the spring is a tremendous expense. And then the added expense, the somewhat indirect, is the method that you have to use in pruning so that you can do this. You have to have a series of vines, literally, at each location in different degrees of age, because as the trunk gets stiffer and stiffer with age, you're not going to be able to lay it down. But if you have a succession of 3 or 4 of them coming along, 5 years, 4 years, 3 years, 2 years, 1 year, then as this one gets too stiff, you eliminate that and then work with the others as they're coming up into production. Fortunately, in California, we don't have to do that. And even in Washington, they are finding now that they can alleviate some of these conditions with certain cultural practices, which I will not have time to go into at this time. Dr. Cook will probably next spring. Now, the summer climate, the vinifera, of course, likes the dry, warm to hot summer. This minimizes the problems of disease, either fungal or problems of insect depredations. But summers that have moisture, considerable rain, pose real problems in several ways. The vinifera fruit is quite subject to rot, especially as contrasted with certain of the American varieties that are adapted to the southeastern part of the United States. Rotundifolia, for example. There are fungicides and even insecticides now that tend to alleviate some of these problems associated with wet conditions. But for example, in Florida, certainly temperature-wise, it would be ideal, yet it's almost impossible to grow the vinifera in Florida, mainly because of the insect vectors that are very prevalent there for Pierce's disease. We used to call it a virus, Pierce's disease, which is a killer disease caused by a rickettsia type of organism, which was just established last year, which is an organism that's somewhere in the scale between the smallest bacteria and the virus. There are several of these entities now that have been identified in just the last few years as real disease problems. But here's a case where the wet temperatures cause the proliferation of these vectors that in turn carry the virus disease, and then the virus disease in turn, and this is, I call it a virus from sheer force of habit, that is a killer of the vines. Now, within California, well, as I might add then, as a result, it's rather interesting that the climatic limitations, or the climatic requirements of Vitis vinifera, roughly limit it to California geographically, either the wet summers or winters that are too cold, and in some cases both. But of course there are exceptions. They do grow vinifera in the Yakima Valley in Washington. They certainly grow vinifera in Arizona, where the climate would parallel California much more closely. Now, within California, we have localized areas of production for quite a variety of reasons. Temperature, of course, is dominant, because characteristically, the areas of California where we would have any inclination to grow grapes are usually dry enough in the summer so that there is no wet summer problem. But of course, within these areas, we have been found by experience that depending on the use that the grape is to be put to, can determine where it is best used or best grown. Certainly, if it's growing for raisins, you're going to need a lot of hot weather, not only to mature the fruit to a high sugar level, which is basically what you're growing is sugar, but still have enough heat in the fall to dry this fruit on the ground between the vines. And this requires a very high heat summation indeed to do this. And it's only in the lower central San Joaquin Valley where the practice can be done with safety. There used to be an extensive raisin industry right around in Woodland in this area here, but because of the hazard of rain, that industry faded out many years ago and came into the lower San Joaquin Valley. Within California, then, we have the heat factor, and thinking of wines, the significance of temperature becomes even more exact. And I would like to call your attention to this handout here when we get into what we call temperature regions. If you'll kind of see that these get distributed around. If anybody winds up without one, hold up your hand. I'm sure there are enough for the whole group. Oh. The monkey forgot he was on the cord here. In fact, I'd better hold my hand up. I gave away all my copies. You came out even there? If somebody has a spare, hold it up. I'd like to have it. Now, this is actually right out of the textbook, but let's take a close look now at this map of California. Notice the region with the slash marks from upper to lower left. Region 1, 2,500 degree days or less. Region 2, 2,501 to 3,000. Region 3, 3,000 to 3,500. 4, 3,500 to 4,000. And then Region 5, 4,000 degree days or more. Now, by definition, a degree day is the number of degrees above 50, or rather the mean of the temperature above 50 degrees for one day. For example, if we had a day in June that had an average of 75 degrees Fahrenheit, that would be 25 degrees above 50. So the heat summation for that particular day would be 25. Now, to make it simple, if every day in June the mean was 75, we would have 30 days, or a heat summation of 750 degree days for the month of June. Now, for seasonal purposes, we start from April 1. That corresponds pretty much to the growth period of the vine and extending through October. Now, why do we use 50 as the base? Question?
What was the end of the...
October 30, yeah, the end of October. The table at the bottom actually gives the span, and we'll get to that in just a moment. Arbitrarily, 50 degrees is considered the 0 point as far as vine growth is concerned. In other words, at temperatures below 50 degrees Fahrenheit, there is practically no shoot growth on Vitis vinifera. And, of course, the assumption is made then that above 50, all of these responses that we want to measure are linear with temperature. Well, of course, we have reasons to believe now this is not true necessarily, but still it is a very useful guide, yardstick, in determining the adaptability, or rather the suitability, of certain districts for certain varieties of grapes, or for the purpose that you intend the fruit to be used. And this is especially true for wine grapes, particularly in the premium wines. You notice that the regions 1, 2, and 3 are largely restricted to the coastal districts and valleys. And this is largely because of the ventilation of these valleys by the cool breezes moving in from the Pacific. Now, so far as the Sonoma district is concerned, Napa Valley, the Livermore Valley, and the Santa Clara valleys, it would be air that moves into the San Francisco Bay Basin through the Golden Gate area, the Carquinez, and then the Carquinez Straits out into the Great Central Valley. I like to think if you could lay your hand on a map of, if this is the California, roughly here in this area, and here's San Francisco Bay, if you can lay your hand with the wrist, say, roughly on the Bay Golden Gate Bridge, then these fingers would extend out into those major districts. Napa District, or rather the Sonoma District, Napa Valley, Great Central Valley, Livermore Valley, Santa Clara Valley. The closer to the bay, of course, the cooler the district. This Great Central Valley here, the main stream of the air going through the Carquinez Straits has its effect because indeed in the Great Central Valley, the coolest area all the way from Bakersfield to Redding is in the Modesto Lodi district because it gets the greatest effect of the cooling effect of the ventilation from the Bay Area. And you notice in there you do have some Area 4 in the Lodi, particularly the Lodi district, and west there into the Delta. Whereas as you go both north and south, very quickly you get into Region 5 country, which is the hottest. Now, there is another district that's causing increasing attention, and that, of course, is the Salinas area down just below Monterey. And that, of course, didn't enter into this crude demonstration here, but the same principle holds. It's the cool areas there in the Salinas Valley are because of the ventilation coming in across Monterey Bay and on up the Salinas River Valley. There again, your temperature gradients follow this. The coolest is right at Salinas, and as you proceed southward in that valley down towards King City, the temperatures are progressively warmer. Unfortunately, we do not have as extensive a records as we would like in this Salinas Valley, which right now, of course, is a scene of tremendous activity and expansion in plantings of premium varieties. And then scattered out over the state, you have areas along the foothills. You'll see some, even Region 3, where you get up in a sufficient altitude to get degree days that are down in that bracket, below 3,500 degree days. And then clear down in the Los Angeles area, there are, well, Region 4, and then of course region 5 over in the Coachella Valley. Now wherever there's region 5, of course this is the area that is best suited certainly to raisins, dessert wines, and many of our table grapes. Then in region 4, it's essentially, well, 4, 3, 2, and 1. Essentially wines, and at the cooler the region, down towards 1, then you're getting into those wines where the emphasis is more and more on the acidity and on the pigmentation in the wine, particularly the acidity, namely the table wines. Is there any question at this point on the significance or of degree day? I don't want to belabor it because you will hear it again in 116 if you haven't already. Yes?
How do you do the summation for the average temperature of the day?
Take the maximum and the minimum. The average is one easy, convenient way to do it. For our purpose, this is close enough. Of course, you could get into some fancy measurement of curves to come up with an average that might be a little more, agree more closely if you took the actual temperatures each hour of a day as a calculation basis. But the maximum plus the minimum divide by 2.
If the minimum is under 50 degrees, do you take 50 degrees as the minimum?
Well, it's a good question. Well, that's never come up before. Actually, you shouldn't, but on the other hand, by definition, we assume the vine to be below 50, you see. So you're kind of caught in your own definition. I would say you probably would come closer to the real figure as far as the vine's concerned by using the actual temperature, but it doesn't, fortunately, involve much of an error because we aren't dealing too much with temperatures below 50 by the time you have passed April 1st and up until just about this time of the year. You're going to have very, very few hours, you see, involved in temperatures below 50. It's a good question, though.
I don't know. I think that lots of parts of California, the convention has been to use just 50 degrees. I just wasn't sure.
Well, for simplicity, I would use it. But at the same time, academically, I'm a bit curious myself as to, because there is evidence now in, I was going to say cyclotron, in phytotron growth, that the vines do indeed grow below 50 degrees. So you get into a rather fine points here of quantities actually you're involved with. By the time, though, I point out some of the other problems here, this one probably pales into insignificance is when we get into the non-linearity of the vine response at the higher temperatures, which introduces probably a far greater error. Now you understand this is strictly a measure of heat. Many times, both the staff here and certainly in industry have been puzzled as to why, for example, a Pinot Noir wine produced in California in region 2 or 1 does not appear to be the same as a Pinot Noir produced in an area in Europe along the Côte d'Or of the same heat summation value. Now, for example, if we look at the table, mean monthly temperatures, let's pick Beaune, France, about midway down there, which of course is the center of the Burgundy area. And we see that we have 2,400 degree days for that area. And on both sides of it, we can find areas in California that parallel that very closely. Sonoma, in fact, even slightly cooler, and Boonville, just a shade over it. And yet it's the opinion of many people that the wines produced, Burgundies from Pinot Noir, are very different. Well, of course, there can be a whole host of reasons, soil types, but we know now that probably one of the big factors that's not taken into consideration here is perhaps day length. Now, that area in France is about in the same latitude as the state of Washington, Yakima Valley, as a matter of fact. And so during the summer months, these grapes are being exposed to much longer days, more hours of daylight, or perhaps we might say not only just daylight, but more hours of temperatures that are a little more moderate than our shorter extreme peaks that we get. In other words, our diurnal fluctuations, to get the same heat accumulation rate, we'd have to go to pretty high peaks to offset the lower ones each day, whereas in France, under slightly more moderate conditions, those peaks each day are not going to have that magnitude. Yet, on a mathematical basis, following the heat accumulation principle, you would expect the same rate of heat accumulation in both districts. Now, this becomes very interesting in lieu of much recent data on the actual response of the vine in terms of the different chemical constituents in the fruit. The rate at which a vine accumulates sugar or the rate increases at X rate from, say, 60 to 70 degrees Fahrenheit, and perhaps even at the same rate of increase from 70 to 80. But it does not increase at the same rate from, say, 80 to 90, or certainly from 90 to 100. In other words, it is not linear, but curvilinear. As a matter of fact, as we go into the course further, we'll find that that rate of increase with temperature go up and then slopes off. And as a matter of fact, we get into an actual depressing of the accumulation of sugar, which of course is the end product of photosynthesis. Now, it would be reasonable to assume that this fact may be why we could get different responses, and that why heat summation may not be necessarily a complete parameter by which we can predict the balance of the constituents in the grape. Now, in acid, the organic acids in the grape, another very important component, are also affected, not on a linear basis, but curvilinear. Plus an additional factor, and that is that the acids certainly are not synthesized linearly as you go up that scale from 50 to 100 degrees Fahrenheit. But in addition, there is the acceleration of respiration that will actually destroy those acids at increasingly rapid rates as the temperature rises. Now, both of these factors then could alter drastically the composition of the grapes. Right now, our viticulturists in Washington are very interested in this. They get too much acid in their vinifera grapes up there. They want to dilute their wines or their grape juice, because many times they will have total acid contents well above 1 in their musts for table wines. They're in the same latitude as I mentioned in France. Those long days, and presumably there is quite a difference in the soluble solids total acid balance than there is in California conditions, even in our cooler districts. Yes?
If they had an acid over 1, what sugar would they have? What volume? Or
well, we're thinking of normal maturity at something from 20 to 22 or 3 degree Brix. Is there any question about this Brix Bowling term? The trend now is to get away from the degree Bowling and use degree Brix. For our purposes, they're synonymous. It simply means there was a man by the name of Bowling that originally devised the soluble solid scale, and then Brix came along and made some improvements on it. The processors picked up the term Brix for syrups and so forth, and the trend in the wine industry picked it up, and the grape viticultural industry, I think, will start picking it up. They use the term Bowling, but I don't want any confusion. For our purposes, Bowling or Brix is the same. It's based on a sucrose, gram sucrose in grams of water solution. In other words, if you had 20 grams of sucrose and added distilled water till you had exactly 100 grams of solution. That would be a 20 bricks solution, or Balling. You understand, of course, when we have Balling or brick, it also includes this soluble solids other than sugars, namely the acids, but that usually is a rather small to very small proportion, but I won't get into that now. Sufficiently so there's no confusion on Balling or bricks. Notice that there are very few areas in France, or in Europe I might say, that have the high heat summation values that we have in the San Joaquin Valley and in the Coachella Valley. An exception, of course, is Algiers, Algeria. It almost didn't get on the map here, which actually has more even than Bakersfield, but certainly not more than the Coachella Valley. Now, Coachella Valley wasn't included here, and I think one reason Professor Winkler didn't is that it's strictly a table grape growing district geared to producing very early grapes. So actually, the grapes are all harvested and gone before even the middle of July. So you are actually using only the very early part of the growing season, at least by the definition of this heat summation table. But it could well go up close to 6,000 degree days. But they wouldn't be meaningful in terms of grapes growing and maturing fruit. Geisenheim, Germany, that 1700 figure there is probably about as low as you can grow a vinifera grape, even under the most optimum conditions otherwise, and still mature fruit for a satisfactory balance of sugar and acid for wine. It's the most northerly district. It's over 50 degrees, 52 or 3, I believe, in that district north. Notice that your heat summations through April, of course, are very low, and they peak along about August and then drop off, of course, into October. Now let us focus our attention for a moment on this table 4 there in the corner. My Scotch nature got the better of me, and I thought I'd kill 3 birds with 1 stone and cut out tables and then run them all on one sheet. Notice, well, for example, the variety Carignan, where it was grown in region 1 clear to region 5, the inverse correlation with region, or rather with temperature, and the color, the pigmentation, which is true also of Maduro, Petit Syrah, and Zinfandel. Look at the total acid, likewise, an inverse relationship, which suggests immediately that in table wines, where we certainly are concerned with a good acid level higher than for other types of uses, the emphasis is going to be on those lower temperature ranges, the lower regions. And in color, there is fewer problems in getting sufficient color in the red wines from grapes grown in the cooler regions. Apparently those temperatures are more favorable for the synthesis of the anthocyanin pigments that we're so concerned with. Yes?
Could you explain the color measurement here? What do they use for color measurement?
Well, this was simply they used a standard reference, and I'm not too acquainted actually with the actual technique. Nowadays, they of course would use a colorimeter probably, and even then further refine it to the wavelength at which it would be measured, or wavelengths. But I'm not sufficiently acquainted with this technique exactly how to use it. There are probably those here that are. Is anyone here acquainted with that Vino colorimetric method? Colorimeter method, I mean. But sufficient to say it's just simply a means of comparative density of color without the qualification of the wavelength. And the acid, of course, is total acid as tartaric. Now, we are going to be aware later in the course of the different acids and the impact of temperature on the not only the total acid content, but on the ratio of the organic acids in the grape as they are influenced by temperature. The Pinot Noir, for example, is particularly noteworthy in being high in malic acid compared to most other varieties. In fact, it can be about half and half, or almost as much malic and sometimes even more than tartaric at certain stages in development. It is also known that the malic acid will be respired under hot conditions much more rapidly than will the tartaric acid. So you would then immediately suspect that the Pinot Noir would be more vulnerable to the high temperatures in our hotter regions than would be, for example, Carignan, which is mostly all tartaric acid. Now, are there any questions to this point? Feel free to ask a question at any time. I'd appreciate it, because I'll be glad to shut you off if it becomes excessive. Yes?
What about the effect of humidity? The degree days, it seems to be like the effect of the heat on the vine would be dependent on that.
The water vapor content of the air has quite a moderating effect on temperature, yes. And this certainly is true in Europe. I think part of it is strictly the heat content or heat capacity of the air because of the higher water vapor content. Part of it is also due to the shade effect of clouds. In other words, they absorb and intercept a lot of the radiant energy that would otherwise fall on the vineyard. So it can have direct and indirect effects, yes, in moderating this.
So this is not actually a measure of temperature as much as a measure of photosynthesis that occurs over the...
Well, the vine responds both ways. However, the reason we have reason to believe that it is primarily temperature, because in some of this phytotron work, they found that the light intensity required to pretty much get the green leaf to full photosynthetic activity is quite low. 150-foot candles, somewhere in that order. Which is quite, even in a cloud over the sun, you still would maybe be practically at full capacity. And it'll run in light intensities in our area here will run clear up to practically 15,000-foot candles, which of course is by many, many times higher than is necessary. Interestingly enough, there isn't much decrease in photosynthetic activity at those high light intensities. By the time you get above 12,000, there's a little, but not much. You're wasting a lot of energy, of course. The vine simply can't use it. So we think it's more a temperature factor, because we do know that as this temperature rises above about 85 degrees Fahrenheit, certainly above 90, then you are actually depressing photosynthesis expressed in terms of synthesis of sugar. In other words, sugar accumulation rate drops off when you get above about 86, 87 degrees Fahrenheit. So we feel it is, again, the temperature factor that is dominant. Now, this light factor certainly becomes significant in vigorous, heavy-producing vines in terms of how you'll handle this vine and spread those leaves out so they do indeed get light that's above this minimum level, this threshold level. Because if you keep the light away from the leaf enough, it not only isn't helping the vine, but it is actually a detriment. It can be actually using energy that has to be made someplace else on the vine, because it is respiring, just like all of the living tissue in the vine, and in respiring, it is actually using up sugar. Now, if the rate of respiration, the rate of consumption of sugar exceeds the synthesis of sugar by photosynthesis, of course, it's a free border, so to speak. And that's one of the reasons, of course, now there's a lot of emphasis on trellising methods to spread this leaf canopy out to get greater efficiency of the vine. Of course, there are mechanical harvesting aspects, too, that are considered in this. Did that answer your question? Are there any other questions? Well, I think that's a convenient point right there to stop. I was going to get into the structure of the vine, which will be the subject when I come back on the air, so to speak, which I think will be 2 weeks from today. So looking ahead to the material to pay close attention to will be the structure of the vine and the physiology of the vine. Now, I have secured from Dr. Cleaver the revised Chapter 6 for the new edition of General Viticulture, which will be available next winter, they say. But at least I do have Xeroxed Chapters 6 on the physiology of the vine, bringing in a lot of these concepts, and also Chapter 8 on the chemical composition of the grape. Those are on reserve here in the Viticulture Library. So that I would say perhaps from the standpoint of our course, 105, these two chapters have perhaps, the changes in these chapters have perhaps the greatest significance of any of the chapters that have been revised in the new edition of the text. No questions? You're ready for Section 1, Wade, in 1014.